Yeah, so I have a very interesting questions here. Some of the questions come from Cape Coast in Ghana, and some of the questions come from Tanzania and other part of the Africa, you know, Egypt, South Africa, and even some from Nigeria too. And some of the questions here come from United Kingdom. It came from some of the A-level student and some of the first year student. And just to mention, without forget to mention one of these questions, it was sent straight from India, from Indian student, you know, and I'm so appreciative that, you know, a lot of Indian students, they always send me questions just to challenge me. Very interesting. I like this. Let's get started. So now, question number one, they say integrate that one. So let's get started. So now you say integral sec x. So what I'm going to do, I want to introduce something here, you know, which is going to help me to do substitution. So I'm going to do sec x plus tan x, and then over the same thing, sec x plus tan x, and then here we still have our dx. So look, this is the same thing. Means it can just literally cancel to each other. It's like a 1. So it did not have any effect on the question, because if you cancel, it's going to be 1. So now we're going to say now multiply that out. So it's going to be integral. Multiply is going to be sec square x plus tan x sec x, and then we over sec x plus tan x, and then we have a dx. But look, I can let this, let's say u equal to this, sec x tan x, or you can say tan x sec x, whatever you want. Okay, so I'm going to say let u equal to sec x tan x. Oh, my pen is getting finished. Sec x plus tan x. Let's differentiate. When you differentiate, this can be du. Oh, my pen is getting finished. And then when you differentiate this, sec x is going to give you sec x tan x. Yeah, thank you. Plus, when you differentiate tan, you get sec square x dx, because you differentiate with respect to x. No, look, this sec x square plus sec x tan x means this one, sec x square plus sec x tan x. So we can replace this one on top with a du, because it's equal to du. So I'm going to say it's going to become integral of du. I'll replace all of this, because this is the same thing, sec x tan x, du, and then over, it's like 1 over sec x tan x equal to u, so we say over u. But when you integrate one over function, it's like somebody gave you integral of 1 over function dx. This same is say 1 over derivative function, and they say we write derivative, say ln of whatever function you have here. This is absolute, and then you plus constant c, because we don't have no limit. So same here. So this is going to become, we have to derivate u. So what is a u for this case? Excuse me. When you derivate u, get 1. So it's like 1. So it's like 1 over 1, because when you derivate u, you get 1. So I don't have to write nothing. So and then this is going to become ln of u. But what is our u for this case? We know the value of u. So u equal to sec x tan x. So it means if I integrate sec x dx, this is going to give me ln of u. What is our u? U equal to sec x tan x. So I can say sec x tan x, sec x plus tan x, and then we plus our constant c. Why we plus constant c? Because we don't have no limit. Let's go to question number 2. So question number 2 is integral, but it's going to turn to be arc10. I know for a fact it's going to be arc10. Okay, I think it's going to be, let me try to predict. It's going to be 1 over 7 arctan x minus 3 over 7 bracket plus c. So 1 over 7 arctan bracket x minus 3 over 7 plus c. Let's see if I'll get it. I'm just trying to predict. Okay, so now first and foremost, I'm going to have to break this into completing the square. So what does that mean? Look, by completing the square, we learn. Oh my god, my pen I finished, guys, so I'm just struggling here. Okay, x squared. Oh my god. X squared minus 6x, and then plus 58. So I'll separate this. This and say x squared minus 6x, and then I'll leave a space. I'll write plus 58 space here in between. So what I'm going to do, I'm going to add, take this number which is in here, divide by 2 and then square. So if you take -6 divided by 2, it's going to give -3. When you square, it's going to give you 9. So it's going to be 9. Take the number divided by 2 and then square. Same thing. If you plus here, you must minus. So it's like it doesn't have any effect. So what I'm going to do, this is a perfect square. This, let me say x minus 3 square, and this is going to give us 49 plus. So this one here, or you can say 7 square. 49 plus like 7 square. So I can rewrite this question. Like I said, this is same integral 1x minus 3, and then this is going to become plus 7 square. I can write it as 7 square dx. So this is arctan. You know why? Because we know so we know if somebody give you integral of 1 dx and they give you 1 plus or a, let's say a, or ffx or a, whatever you can say. Let's say a square or, and then here ffx. So square. This same as say, you say 1 over, take this a with no square, and then also derivate your function. When you derivate your function, guys, look, I'm throwing the pen because my pen are finished. When you derivate this ffx, it's going to give f prime. You're right here behind. And then here say arctan, or you can say tan e this, or whatever you can call it. And then write your function with no square. And then divide by a. And then you plus constant for this case because you don't have no limit. So if you come back here, so why you do this? Because if in the form of this way, and you can see this is a form of tan, because look, you have a plus and everything. Plus this is going to be a function, so then it's going to become 1 over a. What is a? A for this case is going to be 7, and you have to derivate this. X minus 1, when you derivate, this is going to be a function. Here you see you have to derivate your function. When you derivate x minus 1, it's going to give you 1. So 7 times 1 equals 7, so it's like 1 over 7. So this all is going to be 1 over 7. And then we're going to say arctan. Arctan is like tan inverse. Either you can say arctan or you can say tan inverse. Let me say tan inverse. So I can say tan inverse of a function, this one, which is x minus 3, oh, I think I got it right, over 7 plus, I told you. Okay, now let's go for this one. Okay, let me predict this one. This is going to be 1 plus ln of sin, or ln of sine. 1 plus ln of sine. Let's go. No, it's not 1. Theta plus ln of sine. Let's go. Theta plus ln of sine. Let's go. That's my prediction. Let's go. So what we're gonna do? Oh no, we're here, right? I'm supposed to do this one. Okay, let me do this one because I predicted already, and I will come back for this one. Oh, you want me to come this one? Okay, let me predict. This is gonna be a half ln of x. A half ln of x. Okay, let's go. That's final answer. Let's go. So integral, I'll take a half back. It's gonna be a half back, and this is gonna be 1 over x dx. Okay. So now we know this is gonna be 1 over 2. Whenever you have integral, 1 over function, derivate. This let me say 1 over derivate your function, and then this is going to be ln of a function. These are rules, guys. You know, you can just go to the integral table and then you have to look at it. So if let's say for this case here, you see, okay, it's a lot of ways. Okay, this let me say, so here's going to be ln of x plus constant because you don't have a limit. Or I could have just taken how it was before and say 1 over derivate your function, which is going to give you 2. And then when you derivate, and then you're going to say ln. This is the best way. Say this because you take 10½ and then ln of x. Let's stick to that. So ln of x. Okay, because the half has to go back. Okay, so now let's go to question this one here. So I say this is going to be theta plus ln of sine. Now let's go. So I can just say this same integral sine over sine. Sine over sine equal to 1 plus what plus cos over sine. Cos of sine equal to cot theta and then d theta. So this let me say when you integrate, like you can separate 1 d theta is like a d theta plus integral of cot theta d theta. So this is going to become, when you integrate d theta, it's going to give you theta plus, when you integrate cot, it's going to give you ln of sine. But whenever you have a ln, you must put bracket, ln of sine of theta plus constant, and then you done. This is you get this from integration table. But I can show you how this comes about, just in case it was, oh, how did you know that? I can show you. Look, let me just show you. But most of the time, just give us answer straight. Let me just show you so you understand why. Cot, what is cot? Cot equal to cos over sine. Over sine. Oh my God, man, can I finish, brother? Cos over sine theta, and then we say d theta. Let me let this equal to u. So I can let u equal to sine theta, and then when you differentiate u, you get du, and then when you differentiate sine, you get cos theta and then d theta. So this is going to come and replace this, which is going to become du. So then it's going to become integral of du over u. This time we say ln of u. So can't you see? So what is ln of u? Ln of u equal to, so ln, but don't forget your absolute, u. What is that u? U equal to sine of theta. So this just in case if you want to know how that comes about. 1 plus and c because you have no limit. Now let's go to the last question. Last question is going to be 1 over 3 ln absolute 3x. Ln absolute sec 3x. So I predict this is going to be, let me predict, it's going to be 1 over 3 ln of sec 3x. Let's predict in c plus c because there's no limit. Let's go to the last question. Okay, let's go to the last question here. So last question, okay. So this is going to become, look, so what you're going to do, you have to derivate this. Come on, it's obvious. Derivate, because when somebody give you integral of ln of tan of a function dx, this time I say 1 over derivative function, and this could become ln of sec of your function, and plus constant because we don't have no limit. So we're going to do the same thing here. 1 over derivative function. What is your function for this case? 3x. When you derivate 3x, you get 3, and this is going to become ln absolute sec of our function, which is 3x. Don't forget to plus your c. Why plus c? Because we don't have no limit. Yes, exactly. I got it. Correct. Okay, cool. So, look, man. Don't fight. Don't feel shame to do donation. You know, I believe you learn from how to do things. You know, you learn how to do things, and leave a comments. I'll respond to your comments. Also, subscribe. If you face time here, don't forget to subscribe. Share this video because sometimes it might not be useful to you. You might say like, oh, this is not what I was looking for, but you can share it to the other friends. Share the channel, share the platform, so we can help as many people as possible. Like I say, don't feel ashamed to donate $5, $1, $1,000, you know, $50, even if it's 50 cents, just do it for me. I appreciate it. Don't feel shy, man, you know what I'm saying? Yeah, so thanks a lot for your time, and I appreciate it. Peace. Amen.